Now let's connect integer types to CPU. Integer arithmetic is mainly handled by execution hardware associated with the ALU. ALU means arithmetic logic unit. It performs operations such as addition, subtraction, comparison, logical decisions, and bit operations. If you write int total equals 1,000 and 200 plus 800 semicolon, the processor interprets the values as integers and performs integer arithmetic. Characters and many state values can also be presented through integer codes. This is why these categories often connect naturally to integer processing logic inside CPU. From a software perspective, the important lesson is that the type tells the machine how the stored bits should be interpreted. The same sequence of bits can carry different meanings when the program applies different representation. Now consider values that contain fractional information. Examples include geographic coordinates, probabilities, and measurements. Two floating point types are float and double. A float commonly occupies 4 bytes. A double commonly occupies 8 bytes and provides much higher efficiency. Consider driver location in New York like this. Small changes in this number represent real changes in inflation. The application may also calculate routines and from the same coordinates. From this reason, double is useful choice for geographic data. For example, this part, the important concept here is significant digits. Addition applies to the whole number rather than only digits after the decimal point. Money gives us a special case. Suppose a customer buys a meal for $19.99. The value looks like a decimal number. A financial system can represent it more safely as a cents. Int price low license equals 1999 semicolon. $5 refund becomes 500. A 42.75 order becomes 4275. The user interface can convert the integer back into dollar when it displays the price. This design works well because many decimal fractions have approximate representation in binary floating point system. For counting, exact same level arithmetic is usually useful. This becomes important when the system calculates tax refunds, platform fees, restaurant settlements, and repeat financial totals. The basic requirement for exempt money leads directly to an integer representation. That produces another important idea. You see, char is closely connected to 1 byte of storage. For basic English text in UTF-8, many characters use 1 byte. A string such as Joe's Pizza is therefore relatively simple. Now imagine a restaurant called Joe's Tacos. The accented character uses a different byte representation. A customer may also write "leave at the door." Emoji can require several bytes. So this declaration provides space for 100 bytes. It does not always mean 100 characters. C strings also use terminating \0 byte to mark the end. This is why front-end limits, API validation, back-end storage, and the database definition should use constant rules for text length. Some fields represent states rather than measurement. For a simple two-state field, Bool works very well. For example, Bool notifications no line enable semicolon. The field has two meaningful values, enabled and disabled. An older workflow is more possibilities. It may move through placed, confirmed, preparing, picked up, delivered, and cancelled. And Enum gives this a readable name, like this struct. Now the code can say status equals picked, low line up, semicolon. The business meaning becomes much easier to understand. Enum also give the team a clear place to expand the state model as the product grows. Let's finish by connecting the language syntax back to the engineering process. Consider undesired char quantity equals 1. This line creates a variable with a time, storage, and an initial value. Now compare extra int user lowline ID semicolon. This tells the compiler that a name exists elsewhere. These ideas are code definition and direction. For beginners, the more important point is what happens before we write either line. When a new field enters the system, start from the beginning. Ask how the value changes during its lifetime. Estimate its range. Think about whether negative values have meaning. Consider the recursion. Then decide whether the information behaves like an integer, a floating point value, text, or state. Finally, select the concrete C representation. This is a complete reasoning process behind today's lecture. Like when you see this part, you are looking at a small data model. Each type expresses a decision about the real world. This is a connection I want you to remember from these classes.